Okay, so during our break, we finished the problem. All we did was we substituted the 1/2 in for the expression. And if you just follow these steps and pause and look through it, A, then B, which is B there, and then C, and then D. And so we found out the values of A, B, and C. And so now we're going to go and solve our partial fraction. Give me a second. So what was our integral? It was this to this. So now, bless you. All over 2x cubed plus 3x squared minus 2x dx is equal to the integral. What was our a, guys? 1/2 or negative 1/2? 1/2. So 1/2, and a was over x, plus our b was 1/5, all over 2x minus 1, and our c was negative 1/10, all over x plus 2, all of this dx. So now we've been able to separate this into these terms, and each one of these is a different linear factor, right? And because it's a linear factor, it makes it easy for us to integrate, because when I have something like this, then all these are really is natural log situations. So I can just take my numerator, which are all constants really, or coefficients, and I can pull it out. So I can have 1/2 natural log absolute value of x plus, and this is going to be 1/5 natural log absolute value of 2x minus 1, but the chain rule would have been done here, and so that would have been with this 2x, so I'm going to have to divide this by 2, minus 1/10 natural log absolute value of x plus 2 plus c. And then you could simplify that. That'll be a 1/10 right there. And that would be our answer. Yeah. Mm-hmm. So that is the end of case number 1. Case number 1, again, being a situation where when you factor your denominator, you have different linear factors each time. Okay, are you guys good? Okay. So now let's go to case 2. Okay, so case 2, so each of these cases is really about knowing which situation you have and then separating your fraction accordingly. So case 2. Okay, so we will discover our case after we factor everything, because that's what we're supposed to do. Okay, so here is our problem. We have x to the 4 minus, okay, this one's a bit torturous. Let me give me a second. I think I don't want to do that because that's just torturous. And that'll take us too long. Let's do integral of 4x divided by x cubed minus x squared minus x plus 1.
Oh, you didn't move this space without a description.
Oh, yeah, thanks. Excuse-moi. 4x divided by x cubed minus x squared minus x plus 1 dx. All right, thank you. Now, again, we want to factor our denominator. That is always our first step. Factor the denominator, because that really determines what case we have. So we factored the denominator. Do you guys remember how to factor this?
Like 2
is factor by grouping.
Oh.
You group. You go, hey, these guys have a common factor. I mean, these ones really don't, so their common factor is 1. So what are the common factors here? X squared. And this is x cubed. Oh, goodness gracious. This is when? X minus 1. And then here, I can get an x minus 1 if I factor out a negative 1. And this is going to be x minus 1. Like that. Okay, now technically, what are we going to factor out? We're going to factor out an x minus 1 from both of these terms. So I'm going to have x minus 1, and I'm going to be left with an x squared minus 1, like so, which that can be factored also. So I'm going to have x minus 1 multiplied by difference of squares, x minus 1, x plus 1, which, what's that? That's really x minus 1 squared x plus 1. Okay, so we reviewed factor by grouping, and we did difference of squares, and we put things together, and then this is what we realized. We realized that we have linear factors. Each one of these are linear factors. But the thing is that one of them is repeated. You can have a situation where multiple are repeated, or one of them is repeated. It doesn't matter. But in this situation, case 2 is repeated linear factors. When you have repeated linear factors. So how you do that is, technically you have 3 factors. Okay, because if I count this as 2. What I want to do is I want to expand my integral. So my step 2 would be, it would be a all over x minus 1, one of these to the first power, plus b all over x minus 1 to the second power, and then plus c all over x plus 1 dx. So what happens is you do this for each power. Let's say, for instance, let's say it was something like this. It was x minus 1 cubed and x plus 1 squared. Okay? Let's say we had a situation like this. Then what we would have is a all over x minus 1 plus b all over x minus 1 squared plus c all over x minus 1 cubed. 1 for every single power. Plus, and then you're going to have to do that for this one. So you're going to have d all over x plus 1 plus e all over x plus 1 squared. So that would be a different situation. I don't think they're going to give you something torturous like this, but at least you know what to do. Okay, so you know how, like, if it was a little different, this is what you would have to do. Okay? And then you just end up doing the same process. Okay, do common denominator and simplify numerator. So, excuse me. So what is the a missing? A is needing another x minus 1 and an x plus 1. And the b is missing an x plus 1. That's it. And then the c is missing an x minus 1 squared. And then you repeat the process over again.
Wouldn't the c need x minus 1 cubed?
No, that's a different problem. That's like if we